Okay, hello everyone. Thanks for coming to my talk. I'm going to be talking about using transaction bundles more efficiently. I'll also be talking about batch bundles and various pieces of all of those. So I'm the lead software developer on the FHIR API at Google. And so I will be sort of sharing my experiences over the years of helping our customers scale up to tens of thousands of requests per second, mostly written using transaction bundles. And so what I'm talking about hopefully will not be specific to the Google API, as these techniques should apply to any FHIR server, and in general are just best practices that I've seen from the spec. So what I tend to see is that people start with a certain strategy at a low queries per second, or QPS. And so this might be converting some sort of other document, whether it's like an HL7 message or a CCDA document, converting that into a bundle. It was one message, so they write one bundle, and then they just start ingesting those bundles into the FHIR store. So this works at low QPS. It's fairly forgiving, not too much that you need to optimize. But as you get higher and higher QPS, you need to start considering more things. Strategies that worked at a lower QPS aren't going to continue working. And the most important thing to do is always have a load test that's realistic, that uses the data that you're seeing in your production environment. And then whenever you're applying optimizations, always do an A/B test. Okay, based on my load test, is it actually getting better? I have the disclaimer here. Like I said, not all of these suggestions may apply to all systems, but hopefully they at least give you a starting point for where to start optimizing. So I'm going to first talk about the difference between batch and transaction bundles. Sometimes people aren't even sure what the differences are, so this is something that you do need to know. A batch bundle requires that all requests fail or succeed independently. Note requires, so it is not optional. If one of the entries in the bundle times out, if you get an intermittent error from your database, that's not supposed to affect other requests in that same bundle. So that could be slow if your FHIR server is trying really hard to make sure that all of those requests do not impact each other at all. On the other hand, transaction bundles must succeed or fail together. And this can be slow if you're trying to manage parallelization, multiple clients. And so that's what I'm going to be talking about primarily. But if you don't care whether it's it all succeeds together or they're all independent, maybe try both. In the case of our server, due to implementation details, if you do a bunch of GET requests in a transaction bundle, it's actually more efficient because we'll batch those together. We can read them all from the database at the same time. If they all fail, you can reissue the bundle. But in that case, it does work better than batch, even though batch isn't a transaction. But the first thing you need to look at when you're trying to write at high QPS is try to write at a lower QPS. And so, like I said, people will sometimes map from a specific message to a bundle. You don't always need to create every resource in that bundle every time. And so if you have a shared resource like an organization, like a practitioner, ask yourself, why am I writing this every time? Why am I mapping this out of the source data? Maybe you have many different organizations, many different practitioners. In that case, great. But if you know based on the upstream data source, all these things are coming in from the same organization, don't do that right. The other option you can take is to do client-side caching. So you can read the data from the FHIR server, cache it locally, and then before you go and do a write, as part of your mapping process, see, does this data actually need to be updated? Is it the same as what's in my cache? And in that case, don't do the write. Save yourself the traffic on your FHIR server. And then obviously, if it's already in the cache, then you can just hit the cache for your reads and have some sort of expiration policy. So I think the core of what I want to talk about revolves around locking. And this is why I said transactions are kind of where these problems start to come up. So again, this is technically an implementation detail, but I do believe that the way that the FHIR spec is written kind of requires servers to end up doing this, which is to basically turn transaction bundles into a SQL transaction. If you're using a NoSQL database, it might be different, but I assume that stuff like this still has to apply. And so the reason why this happens is you do a bunch of writes, then there's an error, there's a conflict with an ID or something, it needs to roll back. You're just going to use the SQL rollback mechanism to do that. And so the way that these SQL transactions work is you usually start with read locks, which can be shared amongst many readers. And that lets you, say, query if the resource already exists, which tells you whether you need to do an update create. If you're doing a post in a transaction bundle, do you need to return an error because it already exists? But those locks don't stop other transaction bundles from running. They will just all share it. But then as soon as a transaction bundle needs to do a update, like it's doing a put, it's going to request an exclusive lock on a particular resource. And so that is when your concurrent changes from your many different clients start to conflict. So let's say we have two bundles, both trying to update organization one. The first bundle might promote its read lock to a write lock. That is now exclusive. Bundle number two that's also updating that organization has to wait until the transaction is durably written, and then it can acquire that write lock and proceed with its own. So as you can see, you're effectively limiting the throughput of your entire bundle based on that one resource that you've chosen to write in two different bundles. That might be the correct thing to do, but it probably isn't for some resource types. And so typically databases won't let you update the same row many times per second. It's much, much lower than the total number of times you can write to the database. So this causes a trade-off between bundle size. And this is, again, where you need to pull in your load test, see what works best for your system. A larger bundle means you have one big request. It saves on coordination. It's easier for your client. But you're holding any write lock for longer. Anything that you're writing in that bundle is going to be locked for the whole time the bundle is executing. If you have a smaller bundle, you're sending more requests from your clients, but the server can make those changes durable faster and unblock parallel requests. So I've kind of encoded this in an example here. We have an organization that appears in every bundle. It rarely changes this ever, and maybe this isn't even the source of truth that you should be using for your organization data. Then we have a location and practitioner. These are relatively commonly shared. They also rarely change. And then we also have a bunch of observations that are getting written, and they are never shared, they never change, they're completely unique. So in these cases, caution should be exercised before updating the organization, location, and practitioner, because you need to ask yourself, how many parallel updates are you doing on these resources? So there's other ways to manage concurrency that don't require just locking everything, writing everything all the time, and actually can make those situations better. So when you're doing a read, you can say, don't return this resource if it hasn't changed. And so this lets you update your cache. You can say periodically update your cache and say, okay, give me back the organization if it's no longer version 1. You're probably going to get back a not modified response, which means you don't have to update your cache. And then there's an equivalent header for doing it based on the time. So if you want to update your cache every 5 minutes, you can do that with this read header. Similarly, if you're doing a write, you can say only do an update if the current version is version 1.2.3. So this lets you manage your concurrent requests, because what tends to happen, you have two requests that are both competing to perform an update. Say it's on a patient, and then you don't want both of those updates to go through. You only want one of them to go through, and so one one request is going to actually perform the update and the other won't. This doesn't so much help with performance, but it does help with correctness. It means that you're not going to inflate the history of the resource unnecessarily, and just overall. You might also get signal if you're seeing a lot of writes coming back as like precondition, failed. Maybe you need to re-architect your system so that you're not having so many parallel updates to a patient, because that is a signal that your bundles are competing with each other and they're going to be slowing each other down. But overall, this is similar to the client cache. So don't do work that you don't have to. And if you can avoid work, then you don't acquire exclusive locks. Everything can run more quickly. So this is an example of doing that parallel write that I was talking about. And this is on the create side. So one of the things that I've seen people run into as they start increasing the QPS is they start to get duplicate resources, because they have multiple clients that are all that might get a notification that says like, oh, there's a new patient. I need to go create that patient resource. And you end up with duplicate patients. So conditional create is using a similar header to the if match over here, which says only do this create request if the patient does not exist. And so you can see over here that we have client 1 and client 2 are both trying to create a patient, and they have an identifier from the source system. And so the first client gets the lock. The second client tries to make the request. It blocks. It has to wait until client 1's request finishes, but then it sees that the patient has now been created, and it doesn't have to do the create. So your system may not have as strong guarantees as this, because this header does use search terms. It may not be done at a transactional setting. So your server may have a strong guarantee where it actually does hold a lock, and then it might have a softer guarantee where it does a search first and then does an update. And so in that case, you're not holding locks, but you do potentially have correctness issues where you do the search first, you see that the resource doesn't exist, but then by the time you actually get to the database, it does exist. And so you'll need to evaluate trade-offs with load testing to see, do I need to use the server conditionals? Are they good enough? Or do I need a client-side cache? Can that help me instead? And so I have a final slide here that's sort of general networking best practices, a bit of a grab bag that also can be very important. And the first thing I have here is back off and retry. When your server is overloaded, when it's returning 500 errors saying that gateway issues or other internal errors, you need to allow the server to recover. It's not going to get better if you just keep hammering a server with more and more requests. It needs to work through a backlog and get what it's already trying to do processed before it can accept more requests. This might happen if multiple clients are trying to update the same resource, or other situations like that. Updating the same resource is where we see this the most. And so backing off and retrying can break up those data races where two clients are trying to update the same resource at the same time. And so my diagram here shows that not only do you want to retry with a back off, give the server more and more time to recover, work through that backlog, and get those requests processed, but adding random delays can avoid those data races, because if you're always retrying at exactly the same time, you're all just going to conflict again. You're going to hit lock contention, and the server is going to error out. So breaking up that the lock step for your different clients is very important. And then the final issue that I have seen that can be pretty important is a lot of programming languages don't let you reuse TLS connections by default. Node specifically, Go, much better, does it automatically. And so TLS is fast. These are not the early 2000s. We don't have to worry about this being like a major blocker, but it's not fast enough that you can just ignore it, create new connections to the server every time. And so if you do have the ability to reuse TLS connections to a server, it can actually make a big difference. Also, testing with curl in a for loop is not a performance test. It will not work well because of the TLS issues and other things. So just please don't say I ran a load test, which was curl in a for loop. So that is my talk. I'm happy to get into more detail about any of the things that I discussed here. You can connect with me on Huva or LinkedIn if you do mention DevDays. But otherwise, I'll be around the Google booth for tomorrow.
Thank you, Nick, for the presentation. Any questions?
So I don't know if it's out of the topic, but what is the, when should I use transaction instead of batch? The use case.
So I would say to start off with, do you need all of the resources to succeed or fail together? So like if you consider the mapping case, we see people mapping out a bunch of observations. And so let's say that's your scenario. The observations don't all need to get written to the database at the same time. Let's say you have 100 observations. Let's say it's like a bunch of blood pressure measurements over the day or whatever. You don't need all of those to go to the database, either all or nothing. You can write 100, let's say 5 fail. You're doing a batch transaction or a batch bundle, 5 fail. Retry those 5, they'll succeed probably, and then you're good to go. So if you don't need that strong durability of all of these observations went to the database at exactly the same time, consider batch. There are cases where you do need everything to get written together. Let's say you have a patient update and you have some other resource that doesn't make sense it doesn't make sense to have the update to the other resource without the update to the patient or something like that, then definitely use a transaction bundle because you truly do need those to both be in the database or both not be in the database.
From the last slide, what is the best way to do the load test? I mean the performance test, if not calling the API.
So I definitely want you to call the API, but there are load testing frameworks that are designed for this. So you can often only write a certain QPS per client before you max out a particular client, and then you can only write a certain number of QPS per server even. And like if you're going at really high speeds, you're going to max out like the network card or just like the number of cores on a single server. So then you need to scale up to many servers. So when we run load tests against our API, we're running with hundreds of servers. And so when you're running a load test, you either care about what is the latency, how many parallel connections can I have? So when I'm talking about QPS or both. And so you want to scale up your servers and your threads to as many as it takes to get to that QPS you're targeting. So let's say we want to test the server at 100 QPS. I don't know how many servers it's going to take to hit that server at that request level. So a load testing framework, we have an internal one, so I can't give you a specific name. I know there's one in Java, I think JMeter or something. That might be super out of date. But the point is you scale up your threads and your servers until you hit that level of QPS, and then you look at the latency. And that tells you if the server is able to handle that or not. So if we scale up to 100 QPS, and then we see that half the requests are timing out, they're never responding back, that server is not healthy. But if we get up to 100 QPS and the server is responding back in 100 milliseconds, it's great, it's healthy, you can probably dial that up first. But set the QPS first, and then see how the latency is responding.
Yeah, I asked that because I did some similar with JMeter. Yeah.
Oh,
so
perfect.
It's the same thing. Okay, thanks.
One more question.
Is there any reason you'd use update as create or upsert versus a conditional create?
I think where we normally see conditional create is when the system writing to the FHIR server doesn't have any knowledge of the IDs that are being used. And so that's why, specifically why I use the identifier use case. But I would say upsert is usually preferable. But then again, you may also have those parallel writes. You may need to use the like if version conditionals. So if you don't care about your history getting polluted with a couple duplicates, I would say update create is probably the way to go. But then the conditional create also has the advantage of not competing as much for locks. So if you do have a lot of these, you're only going to do one write to your database. That's going to keep your database happier. It's not spinning CPU cycles to do updates that it doesn't need to do. And at the very least, you could do a conditional create like with an ID. So you can use like underscore ID as your search criteria. Then you essentially get the best of both worlds.
Well, thank you very much for your presentation, Nick.